Okay, so here we're going to take a look at a power series. Now, what is a power series? So we're going to look at just a really basic power series. So called power because it has to do with powers of x. Right here where n starts at 0 to infinity. And right, this is 0, x to 0's power is 1, to the first power, x to the second power, etc. Right, so this power series here, right, a more basic one here is, you can think of it like a geometric series, right, where for the absolute value of x being less than 1, it converges, and for the absolute value of x greater than or equal to 1, it diverges, right? But not only that, further we know what the actual sum of this series is. Right, it's the function 1 over 1 minus x. Right, so in fact, what we're going to start to see here is that we use power series to approximate this function, right? And this being you can think of this as our first kind of function represented by a power series, right? So we have some kind of rational function that's represented really by an infinite polynomial here, right? For values of x that are less than 1. Right, so here's just a brief graph of what we're doing here, right? So if you see here on decimals, right, you'll see the two dotted lines here. The black one here is the 1 over 1 minus x, the function, and then the orange one is going to be the sum, right? Now, not infinite, of course, because here we're dealing with a actual program here, so not infinite terms, but we could see kind of how the function starts to take shape, right? What you see here in the dotted line, the orange dotted line, is just the first term of the series, right, where n is 0, right, which is just the function 1. Right, now as we let this play out, the values of n are increasing, right, and then you can start to see, right, 5, 6, right, each of these represents that polynomial, right, in that power series that we have here. And you can see the further out we go, right, the closer it is to that function, right, it becomes a better approximation. All right. So that's going to be our goal here in this chapter here, this idea of a power series, is to approximate functions, right? And we start with this basic one, right, based off of the geometric series, right, where it converges, right? If we think of the number line here between -1 and 1, right, it converges here. And you can think of 0 being in the middle there, kind of centered around there. So it converges. Everywhere else, it's a divergent sequence, and it does not converge to this 1 over 1 minus x. Right, now, the most general power series that we'll be looking at are the ones that, I mean, the defining aspect is these power functions, right? X to some positive exponent. And the C sub n are what are we going to call, or what are called the coefficients of my power function. All right, and they take on many forms here. Okay, so this will be the general form. I have some examples here. All right, let's say we have something like this, n is equal to 0 to the n, x to the n over n factorial. Right, we're again also a power series here, right? We're in this because it has that x to the n, right? And our Cn is simply 1 over n factorial. Right, and the way this looks is x to the 0 over 0 factorial, x to the 1 over 1 factorial, x squared over 2 factorial, etc. Right? For our purposes here, the quantity 0 factorial is equal to 1. So we see we're not we're not dividing by 0, right? We're defining 0 factorial to be 1. Okay, now a type of power series like this, where it's just x to the n, we call that it is centered at 0. Right, now certain type of power series, let's say, for example, here, right, n plus 1 times 3 to the n. Right, so this is a power series as well, right? Because the only difference here, right, in this case, the c sub n's are 1 over n plus 1 to the 3n, right? And it's no longer just x to the n, x minus 2 in the n. This is, now the center is no longer at 0. The center is at x equals 2, right? And what we're going to be focused on here in the next couple of videos is, okay, so we have a power series and I want to determine where it converges, right? Whether it's centered at 0 or centered at some value a, right? What is going to be the interval of convergence, right? As you can see here, when x is 0, right, if it's centered at a, when the value it takes on a, then the series will converge, right? Because here we'll just have 0. Sum of zeros converges to 0. So there's always at least convergence at one point. And we're going to determine what are maybe possibly other points of convergence or intervals of convergence.